Good morning, students. Today we are going to see data dissemination. Data dissemination is the process by which queries or data are routed in the sensor network. The data collected by sensor nodes has to be communicated to the nodes which interested in the data. The node that generates data is called source, and the information to be reported is called an event. A node which interested in an event is called sink. Data dissemination consists of two-step process: interest propagation and data propagation. Interest propagation: for every event that a sink is interested in, it broadcasts its interest to its neighbor and across the network. Data dissemination: when an event is detected, it reported to be interested nodes. It is classified into the loading, IV, each node which receive a packet, broadcast, if it maximum count of the packet is not reached and the node itself is not the destination of the packet. Disadvantage: impulsion, overlap, resource blindness. This is the situation when duplicate messages are sent to the same node. This occurs when a node receives copies of the same message from many of its neighbors. Overlap: the same event may be sensed by more than one node due to overlapping region of coverage. This results in their neighbors receiving duplicate reports of the same event. Resource blindness: loading protocol does not consider the available energy at the nodes and results in many redundant transmission. Hence, it reduces the network lifetime. Hosting, that is modified version of flooding. The nodes do not broadcast a packet but send it to a randomly selected neighbor. Avoid the problem of impulsion. It takes a long time for message to propagate throughout the network. It does not guarantee that all nodes of network will receive the message. Rumor routing: agent-based for creation algorithm. Agent is a long-lived packet created at a random by nodes, and it will die after visit k hubs. It circulated in the network to establish shortest paths to events that they encounter. When an agent finds a node whose path to an event is longer than its own, it updates the node's routing table. See here, rumor routing diagram. This is agent. Agent through we can routing. Suppose you see the table agent E1. Distance is what is that? E1. That is 1 and 2. And event we want to go to C. Direction is C. That is 3. 1, 2, 3. Like that. E2. ET is only 2. 1, 2. Like that. All rumor routing table is indication. Generic queries for E1 pass to here and then random walk to A. Through this we can select a shortest path, that is route for query. That is the rumor routing. Sequential assignment routing. Sequential assignment routing algorithm creates multiple trees where the root of each tree is a one of neighbors of the sink to avoid nodes with low throughput or high delay. Each sensor node records two parameters about each path through it, available energy resources on the path and an additive quality of service metric such as delay. Higher priority packets take lower delay path. The lower priority packets have to use the path of greater delay so that the priority X delay quality of service metric is maintained. Sequential assignment routing minimizes the average weighted quality of service metric over the lifetime of the network. The sequential assignment routing. See this. This is a sensor node. That line is one of link at continue line. That is a tree with 3 4 node A. Dotted line. That is a tree routed at node B. See here. This is a sync node. This is a all are connected A, B and the remaining all nodes neighbor node. That is the sequential assignment routing. Directed diffusion. The directed diffusion protocol is useful in scenarios where the sensor node themselves generate requests or queries for data sensed by other nodes. Each sensor node names its data with one or more attributes. Each sensor node expresses their interest depending on these attributes. Each path is associated with a interest gradient, while positive gradient make the data flow along the path. Negative gradient inhibit the distribution data along a particular path. Example, we can take two paths created with gradient 0.4 and 0.8. The source may devise as much data along the higher one. Suppose the sink wants more frequent update from the sensor which we have detected on event, that is implies send a higher data rate requirement for increasing the gradient of that path. That is the query and the report. In query, type, interval, rectangular, timestamp, expense, these are all available. A report, that is type, instance, location, confidence, timestamp, these are all available. Everything is explanation. Type vehicle, detect vehicle location. Type vehicle in report. Type of intrusion, C. Interval 1 second. Report every 1 second. Instance car, particular instant of the type. Like this, every queries, report, and the explanation is also must. Sensor protocols for information via negotiation. That is, we can simply SPIN uses negotiation and resource adaptation to address the disadvantage of loading, reduce overlap and impulsion, and prolong network lifetime. Use metadata instead of raw data. Spin has three types of message: ADB, request, and data. Advertisement, request, and data. SPIN 2. Using a energy threshold to reduce participation. A node may join in the ADB request data cancel only if it has sufficient resource above a threshold. SPIN protocol using first A2 station. First station ask I want to connect with you. Advertisement, and it will be request ask to data. Then A is send the data. That is the SPIN protocols, rules and regulations. Cost field approach. The cost field approach considers the problem of setting up paths to a sink. The first phase being to set up the cost field based on metrics such as delay. The second phase being data dissemination using the cost. A sync broadcast an advice packet with its own cost as 0. When a node N hears or ADB message from node M, it sets its own path cost to minimum Ln plus Cnm, where Ln is the total path cost from node N to the sink. Lm is the cost of node M to the sink. Cnm is the cost from N to M. If Ln updated, the new cost is broadcast through another ADB. The backup time make a node trigger its ADB instead of immediately broadcast it. The backup time is R plus CMN, where R is the parameter of algorithm. The cost field approach, see here in this time, the sink is passed to the M, then contact with N, then contact to the B, and also that is directly to B. Like this, three cost field approaches here, different sink and different reading, different parameter distance is there. That is the cost field approach. Jackrabbit cost table, which caches the key into Jackrabbit coordinates and store a key and value. That is both where at the sensor node nearest to the hash value. Stored data is replicated to ensure redundancy in case of nodes failures. The data is distributed among nodes such that it is scalable and the storage load is balanced. The routing protocol used is greedy, perimeter, stateless routing, which again uses Jackrabbit information to route the data and queries. A small minimum energy communication network. If the entire sensor network that is represented by G, the subgraph G is constructed such that the energy uses of the network is minimized. The number of edges in G is less than G, and the connectivity between any two nodes is not disrupted by G, so that power required to transmit data between U and V is modeled as P of U comma V, that is equivalent to T into D of U comma V power N, T equal to constant, N equal to loss exponent indicating the loss of power with the distance from transmitter. D of U comma V, that is distance between U and V. It would be more economical to transmit data by smaller hubs. Suppose the path between U of, that is U naught, and V, that is UK, is represented by R, that is given in bracket, but H is in G. Total power consumed for the transmission, that is given in the equation. In this equation, C is the power needed to receive the data. The path R is the minimum energy path. If C of R, that is less than equal C of R dash, for all paths R dash between U and V in G, SMECN uses only the MU path from G dash for data transmission, so that the overall energy consumed is minimized